I turned this on. Yeah, it started loading.
Okay, I think the screen. Okay, uh, I would suggest you to mute the like don't listen the audio from the meet, but try to
Yeah,
listen from
yeah,
the
I stopped
YouTube
it.
live streaming.
Oh, okay, okay. The other way around, because I mean, usually there's a delay between both of them, right?
Yes, yes. So I'm just trying to. So it's like I put ultra low latency in streaming, but I should check how it goes.
Okay. So currently I muted my YouTube live stream. Should I do it the other way around?
You should do yeah the other way around. Just see that am I audible or something like
Okay, one sec.
వినిపిస్తుంది వినిపిస్తుంది.
Yeah, I can hear you. Yeah. Okay.
Okay, that's nice. Then we are all set with the setup. So I'll just put my first talk slide here. Uh, Hello everyone. So we'll be starting in next 5 minutes. So I'll be the first speaker. So let's wait for another 5 minutes. Hello everyone. Is everyone able to hear me? Like if yes, you can just put in the chat saying that yes, we are able to hear you. Am I audible? Like is my voice clear? Hello everyone. So am I audible? If yes, can someone put it in the chat? I couldn't see the chat. Okay. Okay. Yeah, I'm able to see the chat. Sorry for that. So hello everyone. So we'll be going with our first session in next 2 minutes, enforcing policies using Open Policy Agent. So I just want to hear like how many are from Hyderabad, like who is on this meetup today, and how many are from the other places. Please like tell about yourself or where are you from or what session you are looking for today. Hi Varun, it's good that you are from Bangalore. So I've been in Bangalore like last year, like I used to work there and I used to be part of CNCF Bangalore meetup community. So yeah, like that's how we started in Hyderabad. Okay, then I think we have good number of people. We can go ahead, but I'm just waiting for my speakers to join. So that's the only delay right now. So just give me a minute and then I'll go ahead. Hi Vaibhav, hi Nitin, hi Ramanathan. It's good to see people from Silicon Valley attending the CNC of Hyderabad meetup. And we have Shubham from Kolkata and we have Jafar from Hyderabad, Devi Prasad from Udupi. It's good. Like the best part about the virtual meetups is that we get to interact with people from all over the world, and I'm taking it as an opportunity to do meetups like more frequently. So yeah, we used to do monthly ones like every second Saturday, like from past like from August 2019. But now we are just like due to COVID and all this time, and I'm bit facing hard time like finding speakers and all. So yeah, we are a bit slow at this point. But if anyone is interested to talk about cloud native technologies, feel free to reach out to me through the meetup or through Twitter, we would definitely love to have you as a speaker in our one of the upcoming meetups. So it can be anything, not only about technologies, how the adoption in your organization is with specific cloud native technologies, or how was the transitions from virtual machines to containers, and from, let's say, if you are using the Docker, and then how you moved from raw containers to Kubernetes, and how you are looking for multi-cluster. Like, we have uh, too many topics definitely to discuss, and I would love to listen how everyone are using this awesome technologies. Hi Mohan, thanks for joining. Like, OPA session, it's from me. I hope I'll help you with all your questions and doubts. Okay, then let's get started. I'll just go ahead. So, enforcing policies using open policy agent. So, the main, just give me a minute. I think one of my speaker is here. Okay. Hi Andrew.
Hello.
Hi. So we just started the live streaming, and then we have attendees like closely 28 people, and I'm about to
Okay.
start the first session open policy agent. I think Harsh has just, connected the call, but he somehow just dropped from the call. But yeah, like, I just reached out to him. I'll go ahead and
All right.
then we'll continue with the speakers as we have.
Hmm. All right. So I just can hear you, right?
Okay. So let's go with the first session. Enforcing policies using open policy agent. So uh, the main reason why we need a project like open policy agent in cloud native space is that we have so many microservices, and we want to enforce policies, and we want to do a unified policy stack for the microservices environment, which are very dynamic in nature. And that's when the open policy agent comes. And trust me, like, I was using open policy agent right from it, when it was from the beginning, like 2 years back, when I was trying to do an internship with OPA, but it didn't happen. But yeah, I'm right now contributing to one of its extended features. We will go about it as we go further. So, introduction. So this is the definition which we took from open policy agent, which is it is pronounced as OPA in short, and which unifies the policy enforcement across the stack. And when I say like OPA, there are multiple use cases. So even I was thinking to do this talk as complete OPA, like for 40 minutes I'll cover OPA. But then I realized that okay, we have so many use cases of OPA, right from CI/CD pipelines, API gateways, microservices. Like, we have n number of use cases, and it is so flexible that uh, even we can let the OPA community know that this is how I'm using it, and this is what I am taking value out of it. So there are so many things, but maybe in next upcoming 3 or 4 meetups, I'll do an OPA session too, using Gatekeeper and how to enforce policies in Kubernetes. But we'll do this as a getting started thing for now. So open policy agent is also referred as as code stack, and so we can enforce policies between the services. If we are using Kubernetes and we have validation controllers like admission webhook, so where we want to validate, let's say, I don't want to create load balancers in the cluster. I don't want to give container spec as a 5 GB, because the 5 GB will be allocated for that container, and I don't want any external validating webhooks getting created. So this is how you want to validate in the cluster, and for that you need policies. You don't want to write an individual application to enforce policies for each and every service to do that. So we just need a dedicated stack to maintain the policies, to update the policies, and to make sure that these policies are reflected across the complete stack. So why open policy agent? We have so many other tools like we used to do traditionally with other methodologies, but to be very honest, I'm not sure how we used to enforce policies before. But I use in my older when I was doing internship in other companies, so I was looking that they used to write custom applications. This application is like it just runs as a server, and you need to query it, and then this application will respond you back. And if you need to update any policy, it's like you need to go for another release of the application itself. So it was very tiring. Like you have a dedicated application, and evaluation is always like if something has changed, you should change the complete policies. So that is one tiring job. But yeah, how can OPA help us? So OPA is dedicatedly and built thinking that how the cloud native space would be. Like when we see about Kubernetes or microservices with service meshes, like we have extended support for OPA with Istio plugin and Linkerd auth. So how we can do this kind of integrations, like extended integrations. And I know like when we say Istio Linkerd, they come with sidecars, and we have control plane and everything. Everything keeps changing, and we need something for this to handle such workloads. So open policy agent is supports right now all the stacks like risk management at Terraform level, and even the container exec SSH and sudo. Like you can enforce policies to your VMs that saying that only so and so user can SSH into this container and server specifically. And that's when we see the real value of open policy agent. And coming to the architecture, where exactly the OPA sits and how exactly this OPA performs the policy evaluations, this is the diagram. Like you see this illustration right after you get into the open policy agent documentation. So this is your service, your application, and you will be having OPA running as a server in daemon mode, and you will be providing the Rego policy. So I'll come to this Rego part later. So Rego is nothing but a declarative policy language dedicatedly written for open policy agent. And this Rego, you will define all your rules in this Rego file, and OPA server will be evaluating all this Rego policies based on the request come to this OPA. So you should be doing an external HTTP request to the OPA server, or let's say if you are concerned about the network hop or the latency it adds to your applications, maybe you can add it as a sidecar container. Um, so that it will be in the same network namespace if it's Kubernetes. So you can have OPA as a sidecar. Also, the communication between your application and the OPA will be a HTTP request, as I told, and you should be sending the context, like what is the data you want to send for the policy evaluation as a JSON, like as a JSON value to your request body, and the decision would also be any JSON value. And let's say that you have a request comes from a application doesn't have the complete context. Let's say there is a data like I want an employee. There is a employee details. This detail should be only viewed by the employee himself and his own and is by manager. And let's say the employee's manager can change at any point of time, let's say like after 2 months or 3 months. So I can't expect that request to be coming from my application itself. So the request only says that I want to view so and so employee details, and I'm so and so employee. When the request comes, I can evaluate saying that this is the policy, and I want to know who is the manager of this employee. Like I do not know. These are the unknowns for me right now. So we will have an other JSON file called data JSON. So basically in OPA terminology, we say that this policy Rego and data JSON as bundles. So a bundle is comprised of Rego policies and data.json, and this data.json contains all your unknown values. What is the data you want to provide open policy agent to evaluate the unknowns, because all the service request cannot provide the context OPA needs. So you can put the arbitrary data in this data.json file, and the Rego policy will inject the data into this Rego, as well as the context that service provides, and the evaluation happens at the OPA level. So this is the clear understanding of how OPA interacts with the service and how we can inject data. So let's say if you want to update the Rego policies, excuse me. Let's say if you want to update the Rego policies, or if you want to update data.json, OPA also provides a extensibility feature, OPA can poll for every 5 minutes or every hour to an HTTP server and download the latest bundles. So if you want to update any data, you don't need to restart your OPA. You can just point to an HTTP server or a S3 or somewhere. So it just downloads this bundle, and which is a tar.gz file. By default, it expects it to be, and OPA will load all this Rego and data.json in its memory. Also, I see like many questions in OPA community saying that we have data.json and policy.rego. We are providing it in files. Will there be any low latency or response issues, because OPA always queries the data from data.json file and the policy should be here. So the best part about OPA is how fast it is that it loads all the data.json file into its in memory, and even the policy Rego into its in memory. So OPA performs the operations very fast and very quick, so that it doesn't add an added latency to your request. So this is the architecture and the clear illustration how service to OPA interaction happens. And this is how exactly your stack can look like. So this is one of the slides from Kubicon talk given by Torin, I guess. Yeah. It's the same architecture diagram, but what your service can be. So it's 1 year old, so I think one or more application support might have been even added. So your service can be anything like Kafka, Elastic, Envoy, even Kubernetes. So it can query the OPA, and OPA will give you back. So when we say policies, we usually the default way of thinking about policy is that we just ask the OPA, and it says, okay, the request is allowed or denied. It's not only like that. So we have many API gateways like Kong, APG from Google, and all these products. So even you can integrate OPA with this API gateways. So if a request has come, we can also do the data filtering using OPA. You can mention the filtering policy you want to mention, and based on the request, we can OPA will filter out the data and shows, okay, this request is allowed to see only this limited data. So this kind of filtering can also be done by OPA. So that's how I see the value gets added to our use cases and more custom use cases. So, and this is the architecture flexibility. So there are many concerns saying that I don't want to run OPA as a daemon set or a sidecar. You can also have an opportunity. So OPA offers a Go API doc, so you can instrument your applications itself with OPA library, and OPA library will do all the policy evaluations within the application itself. It doesn't have to do an HTTP request anymore. So you can also have it as a library. Library is also an option if you have any advanced use cases that I don't want to hit a HTTP request. And in daemon also, as I told, based on our requirement, you can run it. So I see in most of the cases, like we can run OPA as a daemon set. Daemon set means you can give it daemon set or even a deployment. It necessary, like it's not necessary to be a daemon set. Yeah. And it's the same again, even if you have a Go OPA library within your application, you need to mention the policy.rego file and data.json. It offers most of the features what OPA as a server offers. And what can be evaluated using OPA? So we know, like, now it does some policies, but what exactly are the real time use cases? So these are some curated list of points I took from OPA documentation and put it here, so that we all can understand, okay, what is it capable of? So which users can access which resources? So as I told, like, there are so many resources, you can do filtering, or else you can deny, saying that this you don't have access privilege to to access these resources, and which subnets egress traffic is allowed to. Not only with users, but also in specific to traffic also we can use OPA, and which clusters a workload must be deployed to. So when it comes to Terraform and other CI/CD integrations, we can do such use cases, and registry binaries downloaded from, and OSS capabilities also. And these are some most commonly used use cases. And we have an in OPA repository, we have I think there is a example repository or something with all type of examples how you can integrate OPA with Docker, OPA with Kubernetes, OPA with Terraform, all. So maybe I'll try to find the link at the end and share with you all. And key features. So why exactly OPA adds value? Like why not some other policy agents or something? So policy and data are stored in runtime. So this gives some efficiency to the OPA in terms of processing the queries the applications do. And we don't have any runtime dependencies as of now for OPA. And OPA can be used as any mode based on your requirement, as I told, daemon, sidecar, or even embedded library within your applications. And we have a declarative policy language. So I know, like, I'm just taking a different direction in this talk. So most of the talks we see on OPA talks more about Rego than the open policy agent itself. So it has more to do. So because we hardly deal with OPA, because we always run OPA, just say that dot slash OPA run server, and you'll give a configuration file saying that poll this HTTP server and get the bundles updated for every 1 hour or 30 minutes. More we the users deal with Rego, because that's how you define your policies, and you have so many policies, embedded policies and everything. But yeah, we'll go with Rego also. So policy as code. So declarative policy language can user X do Y on resource Z. Like all this kind of combinational queries also can be performed. And coming to the management APIs and control observability, bundle service API for sending policy and data to OPA. So these are bundles. So even using the HTTP request, also you can send the policies to the OPA, and also you can view the policies from using a policy, like what are the policies right now existing with OPA. So something like that. And we have VS Code plugin to write Rego policies, which makes our job much better and easier. And I think there are some other plugins also getting built for other editors as well. And I see one of the best use case, or I personally like with OPA, is that let's say I have 10 applications which are querying OPA, and I want to know what user have requested what resource. And I want to have a audit saying that I want to know, like, if some malicious request has come and it's denied, it's okay, but I just want to record it saying that a person who is not allowed with this request has tried it. So OPA can also log all the requests. You need to mention a flag in your configuration file saying that just log all the requests and responses. So that lets you log all the requests and responses within OPA level, and over a period of time you can inspect what are the requests, what are denied, what are allowed, and who are what was the request context as well. And coming to running OPA, so one of the best thing I see about open source projects is that it should be as easy as possible to getting started. It should be less than 5 commands to get it started and running. So in Linux you can just use this 3 commands and it should run the OPA. And here test.rego is the Rego file which I have in my local directory, so I added it. So for our use cases, for just running, you can just use OPA run hyphen server. So that runs. If you just run OPA run, this will take you to an interactive mode where you can ask queries in an interactive mode. Like you can say policies and then it results you. And how does an example Rego look like? So trust me, this is one of the easiest policy language I have seen, and it seems complicated the way it looks, because even I was a bit scared initially, but I just understood how it works, and then it felt so easy for me. So We have so this the requirement here is that the rule I wanted to define is that employees and their manager may read the salary of the employees. So only the employee himself and the manager specific employee can view the salary details. So I will mention the policy as like this. So if you see LO here, so I'm saying that LO equals to true. So it's an optional, you can skip here mentioning equals to true, because all the statements you put in this curly braces are nothing but assertions. So it's like and to all these three statements. So if the input dot method is get and the input dot path is get salary with specific name, and the user and the requested user and the salary requested for the employee are same, allow it as true. So this is what I'm trying to mention here. So if the user and the requested user is same, just allow it as true. So that's one requirement. And the other requirement is that if the method is get and the path is get salary name and input dot user is manager, so manager of name. So data dot manager of is not coming from the application for us in this case. So the request is not giving the context of who is the manager of specific employee. So this is one unknown for us, and the input will look like this. So if you do a from your application, you will be passing this body request body saying that the method is get and the path is get salary Bob and the user is Alice. So we want to know like who is the manager of LS for this evaluation, because we want to know whether the Bob's manager is LS or not. If it's not, the request should be denied. So so this data is nothing but the bundle, the JSON file we provide on with to OPA on startup. So it's just a JSON file with key value pairs. I'm saying that manager of, so consider this M should be small, it's a typo here. Yeah, so the manager of Bob is LS, so the manager of Bob is LS here, so the request should be allowed. So that's how we can have unknown data and we can load the unknown data, and this data while evaluation within OPA will be maintained in memory, which is a sign that we will have the faster query latency at OPA level. And demo, we'll just do a small demo, quick demo. So I have the demo application already pushed it here. So I just built it in the morning, like in less than an hour. So yeah, so this is the link to the GitHub URL. You can find the README and you can run it if you are interested with it. So I'll just show you. What shall we do is that, okay. Okay. So I'm just running my OPA server right now. So I'm just doing as OPA run. So it just started, the server has just started. I'm saying that take the input as test.rego file, and my test.rego is nothing but this is the policy saying that whatever the request comes to you, just if the requested details and the requested user are same, just allow the request. If the requested details and the requested user are different, don't allow it. So that's a simple policy which I wrote in Rego. And so localhost, so OPA by default runs in 8081 port, and I want to see the policies. So this is the policy it says. So this is the policy which right now OPA holds at this point of time. If you use some dynamic polling, this policies change over a period of time. And so I have a demo application right now. I'll just show you. So I'll just give you a quick walkthrough. So uh, so we'll just do this here. Yeah. So the use case is that we have a client and server applications. The job of the client is to evaluate the permissions, the request that hit it, and forward it to the backend server if it is allowed. So let's say I have a treasure, like it's let's consider the server as some complicated sophisticated data the server holds. So I don't want to load it with so many requests, or also I don't want to evaluate policies in this server level because it adds added CPU cycles to that process. So I want to have all this kind of evaluations at client level. So I have a client application, maybe let's consider it does some computations and also does some policy evaluations whether the request received is allowed to go to the server. If not, just deny it. So that's the use case. And I have a client application, so I'll just run the client application here. Okay, so I think it's already running. Okay, I have a client running right now, and I'll just restart my server as well. So I have a server also, the server also the running. So I have the client and server running right now. So what I'll do is I'll just open the Postman. I feel the Postman helps us in the scenarios to test it. So I'm just so the right now my client application is running in 8089, and whatever I'm asking is that I'm asking hit employee API with the data as ARIA, and the username is also ARIA. So this is the policy. So it should allow this and it should give back the results to me. So as the policy said, the requested user and the requested data is same. So we need to, so I'm just querying this thing, and yes. So one other thing I can show you as localhost 8090. So my server, so the server I wrote holds this data. So you can ask for details of any name here. So it should result you this data. So my server at 8090 port is holding this data in its in memory, and the client queries server based on the policy evaluations. So if you see here, it says that client and request to OPA server. So the request to OPA server is the method is get, and the uh, path is employee area. So if you see my Rego policy, so I don't have the Rego policy here. Okay, no problem. We have a Rego policy here. So I'm saying that if the input dot method is get and the input dot path is employee name and the name and the input user are same. So and so which is true and will be allowed. So allow will be true. By default, allow is false. So that
Hey Vineeth, can you increase the font size?
okay, I'll just do that. Okay. So this is the policy right now. So this is the policy, and we'll just perform like whenever we write a policy, it's nothing but assertion as I was telling. So and of these three statements should result allow as true, and it will be allowed. And if you see the postman here, so I'm just going in. So yes, and the requested path is aria and will it should result. And let's say the user, the requested user is something else, like let's keep my name Vineeth, and fail to process request for Vineeth. And if you see what my client returns is that, sorry, okay, I'm unable to increase the font here. Okay, so here when I the OPA server, the request is that it's get and the employee area and the user is Vineeth, and the response body from OPA is false because the policy is evaluated as false. And here if you see the above one, it says the response body as true because the policy whatever we are expecting the data as it's true, and we got the response as the complete data set from the server. Here the failed to process the request Vineeth, and at server level also you will not see the request coming hitting the server itself. So this is one kind of rate limiting a client can do, which is already done in many companies. Like yeah, we can do with OPA so that the policy evaluations is away from the main application itself. So This is one demo I wanted to show. So this is very quick demo. Yeah, I was planning to do the bundles part. Then I didn't have much time to make that to extend the application. So sorry for that. Maybe I could extend it for the upcoming session. So we have this data, and if someone is interested, we can also do something like Jamie or something. Okay. And one other point I missed to share is that here, if we see this here, so we have two policies here, LO equals to true and LO equals to true. So if these are two policies, if you want to evaluate two policies, it will be or. So the name, if the policy, whatever the policy key you are mentioning is LO here and LO here, and for some reason you are embedding you are evaluating both the policies in a parent policy. In that cases, we will do an or. If the name of the policy is same, we will just do an or. I don't have an example to show such use case. Okay, so we have done the demo and advanced use cases. So data filtering. So let's say the policies or the context you want to provide to OPA are very big. So you don't want your OPA to use so much of in memory, because if you are providing some unknown context and unknown values too big, they cannot be loaded into in memory, and OPA throttles, and it is not a valid use case for OPA at this point of time. So there is an extensibility features for OPA saying that data filtering. So all the unknown data, like whatever the data you want to mention for policy, which will not come as a context from the request, you can mention it in the uh, uh, SQL database or Elasticsearch database or even MongoDB. So I'm right now currently working on adding support for MongoDB for OPA, so that let's say you have a collection and you have documents in MongoDB with n records, and you want to evaluate policy, like saying that is who is the manager of this employee, or else allow to see the employee details only if his department is IT. So all this data should be is dynamic. Let's say if the employees, managers, and the departments keep changing, so the data will be reflected as the change happens in the MongoDB, and your OPA, based on each and every query, it will OPA query, it will query the backend MongoDB or Elasticsearch or SQL. So this lets you to unleash the power of adding more context. Like you can put like thousands of records in the databases, and the OPA will be translating the Rego queries, and the unknown data will be evaluated from the policies by translating the Rego query into respective SQL queries or Elasticsearch and MongoDB query, and periodically downloading the bundles. So, polling and how long you should poll, and like that is also one of the advanced use cases at OPA. I think someone from Ash from OPA is already working in releasing a blog post of how to integrate OPA with EPG. Definitely, it would be one of the good blogs. So yeah, I'm counting on it to understand more on bundles, and integrating API gateways to with like APG, or integrating with Istio and Linkerd also, like is advanced use cases. And we have a dedicated repo for all this extensibility policies in OPA with a repo name as contrib, and all this contrib contains the data filtering examples for SQL, Elasticsearch, and all this Istio plugins and etc. And coming to the OPA community, so when we are so when we are choosing a tool like OPA or any other project, we want to understand how many are, what is the adoption ratio, like how many are using it, what are the use cases the other companies are using for, and when did it start, and what are the numbers. So number speaks the value, so I usually sees that. So these are the numbers and these are the people using OPA. So OPA was started at Styra, and then it got donated to CNCF. Right now it is one of the incubation project, and I'm definitely waiting for it to get graduated because this is one of the unique CNCF project right now, because I don't see any other CNCF project for enforcing policies to the complete stack of cloud native space and users. Right now, Netflix is using OPA, so there is a amazing talk from Kubicon how Netflix is leveraging OPA. You can have a look and the use cases. So admission controller, when we want to use OPA specifically for Kubernetes level primitive policy evaluations, I think Gatekeeper is the go-to option. So it is also one of the very great projects for Kubernetes like environments to enforce policies on the primitives of the Kubernetes itself rather than our applications. And we can do all these use cases like data filtering, data protection, and everything. And this whatever the picture I'm showing you is from 2019. I definitely know that these numbers have increased. I think it would be definitely more as of now. And thank you. So to know more about OPA, like I would suggest you to join the dedicated Slack for Open Policy Agent, and we have so many amazing folks there who is working on OPA and extending it. Uh, Definitely join Slack and say hi to all of us. So that's it from my end. So we'll just take questions for other couple of minutes before we go to the next talk. If anyone has any questions, like they can add it in the chat. So I'm right now looking at the chat. Hi Ash. Hi Arsh. Sorry.
Hi, everyone. I lost my internet. Sorry for that.
Okay, no problem.
So there are two questions for you. Uh, One
Okay.
of them is from Nicholas. He is asking, how does OPA and K8's network policy and admission controller intersect? Is it recommended to use one or the other?
I'm just reading the question. The voice was a bit breaking. Sorry for that. Where I want to validate trust
Oh,
metrics
okay, sorry. Yeah.
and trace other. So I'm not sure about the network policy, but like I was looking around the pod security policies in the Cubicon and San Diego, and definitely like people were suggesting the alternatives for pod security policies were OPA. We can definitely use OPA and leverage out of it. Maybe sometime soon. I'm just expecting OPA PSPs to be replaced by OPA because it does all kind of evaluations from OPA level. So maybe if I find something on network policy, I'll definitely add back here. Hi Amitosh, we
So
have
another
another speaker.
question is from Shubham, I guess.
Yeah, Shubham. Okay, I have a use case where I want to validate trust metadata of images from a notary server while deploying as a pod. I want to use OPA as an admission controller. Is it possible? Okay. So it's definitely possible. So you can with OPA, the use case is something like admission controllers is that the admission controller will send you a request. The admission controller will just give you saying that this is the object. So in admission controller in spec, we will mention that I'm interested in events such as pods. Like if a pod is getting created or deleted or updated, just give me that request. But OPA, we should manipulate this data in a way that your policy should align with the request we get. So usually for this kind of use cases, like how we'll evaluate such things, we have gatekeeper, so it does all this stuff. But I have another project which I have done 1 year back. So let's say if there are even I work for Aqua security and we have an enterprise product answering the same problems. So we will have an admission controller and we will have a agent running in the cluster. So we get all this request to this agent, and the agent will do all the evaluations, whether the image is allowed or it is the image has some vulnerabilities or something like that. So we do all that. But I'm just thinking like how does Notary server integration works. Okay, validate transmit. I would suggest like you should definitely have a look at Gatekeeper because Gatekeeper is completely works with muted admission controllers more like an OPA. So OPA is you can definitely use OPA, but I would suggest Gatekeeper has more examples of how to evaluate such use cases. Gopal is asking that is this strictly dependent on K8s or can be used with Docker Swarm as well? You can even use this in virtual machines. So right now I was running OPA. So if you see my screen, so I was running OPA as a just as a binary. So you can see all the logs saying that this is the request received for the OPA. So in the same way, you can also run this OPA as a binary. So it is like uh, agnostic to all the platforms. So you can run on VMs, containers, Kubernetes, like it is supported in all the platforms. And we have Mohan. Thanks. It was a nice introduction. Thank you, Mohan. And can we have a next session on how to use OPA in AKS, Azure, for containers? Maybe like if I definitely like uh, if I definitely do a next session, I'll try to add a bit of how to integrating it with other clusters. But I don't think like in AKS or Azure for I did Azure for containers. So if you're saying Azure for containers, it should be like ACI, like Azure Container Instances, like the serverless. For that, I'm not sure how to integrate OPA in such environments like serverless. But in AKS, the same like I think it goes back to the same question of Shubham. So we should have a admission controller or and have the OPA or a gatekeeper to evaluate policies in AKS level so that these images cannot be run. Like if the replication count is 50, don't allow such resources to get scheduled on my cluster. And Aditya. So, hey, could you touch on how OPA compares to other projects like Say and Caspian? Sorry, Aditya, like haven't used any other solutions to compare it, but so one best thing, like the main reason why I went with OPA is that if you see here, the documentation of OPA is really really good. You have all kind of integrations, like you just name it, you have it. So something like that, and you can see, like as I was mentioning, it's not only dedicatedly for Kubernetes. You can see for hosts, API, even for UI. They have an support recently. They added support for WebAssembly, so you can even use policies at UI level. So yeah, so so I was trying to cover it in one session, but I realized that this will never happen in one session to complete all kind of use cases. So yeah, so I'll just go with one or two questions more, Harsh.
Yeah, sure, sure.
Hey, good. Okay. Gopal says that we say that OPA broadly supplements API gateways and interest controllers. No, not at all. So we have OPA is all you can integrate OPA with ingress controllers and API gateways to do some policy level evaluations, but it's never a substitute. So there is another, like I was mentioning, there will be a blog post coming in a week or two how to integrate OPA with APG, the API gateway from Google, or else how to integrate OPA with Kong. I think it's already present as a some project in contrib repository of OPA. And okay, Shubham says he's using Portrees and it is a bit tough considering the poor documentation. But trust me, if someone is planning to use OPA or have a requirement to use such policy-based stack in your microservices, I would say the go-to option should be Open Policy Agent because it has the community support. It is very close to become a graduated project in CNCF, and the community is very very welcoming in Slack. So please join the Slack if you are planning to use it, and you can ask all your questions directly there, like all the custom use cases, because people with broader use cases might answer your questions. So thank you. Thanks for joining the session. Let's go with the next session from Harsh. Harsh, you
Vineeth,
can, yeah,
Vineeth, there's a change of plan. Andrew will go next.
yeah, sure.
He
Andrew,
has
yeah,
to.
yeah, no problem. So Andrew can share his screen. So I'll just share,
All right, so that will be enough for me to share the screen, right?
yes, you should just share the screen.
And
That's it. Yeah.
okay, let's see. Just I think I want to share this one, and yes, it's the right one. Please confirm that you got the picture.
Just give me a minute. I think.
They like. We can see it in the meetup thing. But
All right, so I'm ready when you're ready. Just give me a go and I will start then.
Yes, you can go ahead.
All right, team. Hello, everyone, and I'm happy to be here and join Meetup already. And I want to thank Vineeth for his presentation. I actually haven't been aware that you can use Open Policy Agent with Terraform, and because Terraform has a Sentinel, that's an enterprise offering from HashiCorp, and it looks like that Open Policy Agent might be a replacement for someone who hasn't purchased the Terraform Enterprise. But this is not a presentation I'm going to give today. Today I'm going to be talking about vault configuration as code via HashiCorp Terraform. And HashiCorp recently joined Cloud Native Foundation, so I guess it's all Cloud Native now. That's why I'm here. And yeah, so there are children's books like those that you could use with your kids to build up the ability of finding patterns. Like here, you see like there are differences between those cats, and that might be a nice and good exercise to do with the kid, but it's not so fun to do on your production servers and not when they are on the fire, and especially when you might have a possible intrusion going on. And on that occasion, you really want to be sure that this configuration right here is intended to be here. And this is where Terraform can help. And this is what this talk about. Before we start, my name is Andrey, and I'm an independent consultant. I'm fixing automations, projects, and organizations. Having a bunch of certifications, which is not very relevant for this presentation. I quite often speak on conferences and meetups. Actually, this presentation will be given on HashiConf Digital on Monday, but there it will be 25 minutes version, and here you have a director cut of this presentation. So you have some additional slides and some additional details that people will not see on that conference. So good for you. I also host at DevSecOps Talks podcast. So if you like what you hear today, tune in for more in the podcast. It's available on DevSecOps FM and on all major podcast sharing platforms. So about these presentations and what to expect. I'm not really pretending to be an expert. I'm just sharing what I did with the clients and what worked and what didn't. I might be wrong at some point. So if I am, I urge you to come to me after presentation and tell me what you think. I always eager to learn the new ways of solving those problems. There are going to be technical details and references, and I will make slides available online, so you don't really need to remember photo or screenshot the slides. We start with a little bit of introduction. Terraform, if you're not aware, is an infrastructure as code tool which basically allows you to describe your infrastructure as code, meaning you using the DSL, domain-specific language. You describe what you want to do, and then Terraform will read that, prepare a plan for you so you can validate before you run it, so you can see that it's going to create those objects. And then it will call your infrastructure provider API. So it might be public cloud, it might be your, I don't know, availability monitoring tool like Pingdom. You could even configure GitHub accounts with Terraform. So there are a lot of providers, and the number is growing every day. I guess Terraform is more or less becoming the go-to solution. Another good thing is that you have open source modules. So people who solve the same problems, they actually package those solutions into modules. You can sync them as the libraries, publish them available on GitHub, and you can reuse those so you don't have to write the same thing all over again, which is great. And you can, avoid getting into troubles that some people already got to, because it's not always clear that there will be a trouble along the way ahead of you. So great stuff. And the Vault is another HashiCorp tool, which is a secrets manager. Its primary goal is to reduce secret sprawl, so you have all your crown jewels in one place. Another nice thing about Vault that allows you to generate generic dynamic credentials for certain resources. It's not for everything is supported right now, but again, the number of supported resources growing and growing. Like you can think of your cloud provider dynamic credentials with TTL attached. So even if they leak, they're going to expire very soon. Database credentials and so on and so on. You avoiding using shared secrets, which means that like before Vault, you might have one shared database password, and you have no idea who is logging into your database because everyone have it, and it's the same username on your database log. But here, like everyone gets, every person, every workload, it gets its own credentials, so you really know who it is, and you can trace that. Also, since everything gets its own credentials, if something being leaked, something being exploited, you can quickly identify the source of the problem and revoke only those credentials, and the rest will work. So, I mean, it's great. Also, Vault allows you to work across data centers, across cloud providers, so you could build a hybrid cloud if you want. And as I mentioned, you have a break glass procedure. Since Vault keeps tracks of what was given to whom, you could always revoke secrets if there is a need, say inside dynamic. There is a great video. I'm not going to play it right now, but just Google it, Introduction to HashiCorp Vault with Armand Datka, one of the co-founders of the HashiCorp. He goes in a lot of details about what Vault can do for you. But let's assume that I convince you that you should be using Vault. Where do you start? There is a good way forward if you collect requirements and clarify the context. By that I mean your deployment operations. How you're going to run Vault? Where will you deploy on a VM, on bare metal containers? What is available for you? How you're going to run it? Will it be like long-lived instance that you're just patching all the time? Or will you do immutable infrastructure and you will just scratch it and replace with the new images all the time? How you're going to access it? VPN, public, how to unseal. So the deal with Vault is that when it comes up, it's sealed. When you initialize the Vault, like when you first boot it up, you need to initialize it. You type Vault init, and it will give you, by default, it will give you 5 keys, and you will need to have 3 keys to unseal it every time it restarts. And those keys they use to reconstruct the master encryption keys that encrypts the rest of the data. And that might be cumbersome, especially in the fully automated environments. You don't really want to be around and have your friends with other keys around every time the Vault restarts, so you need to enter them. The great thing is that HashiCorp open source possibility to do that with Cloud KMS. So you can have, so Vault can reach to KMS and get needed keys from there. Then how do you get your initial secrets? For instance, when you're running Vault, you want Vault to do TLS termination. For instance, if you're running on AWS, and I'm going to quote AWS quite a lot on this talk. So if you're terminating TLS on a ELB in AWS and then just passing traffic from ELB to your wherever your Vault is running, between ELB and wherever your Vault is running, the traffic goes unencrypted because you already terminated TLS on ELB. So that's not what you want. Since you might have someone in the middle listening and basically seeing everything that's going on. It's kind of obvious, but I find again and again that's not for everyone. So I feel important to mention this. So you want your Vault to terminate TLS, making sure that it has fully encrypted connection toward the Vault from the client. Then what storage you're going to be using, and to make it highly available and enable the immutable infrastructure. Then another thing is that you want to lock down the Vault box or container, whatever you use, as much as possible. So you want to get everything that you might ever need out of it. So you don't need to log in. So you want to stream logs out. You want to stream telemetry out. You want to extract audit files. You might consider, if you're a big organization, you might consider multi-data center, disaster recovery. How you're going to run Vault? Will it be like one Vault instance per everything, or will you have like one Vault cluster per every environment, like your dev stage prod, or how many you have? So those are valid questions to ask, and they will give you a good idea of where you're heading, and it will help you to see the path ahead. And the good thing is that there are a lot of best practices and templates. As I said, there are Terraform modules that you could use to deploy Vault clusters. Gruntwork has one. There is a Helm chart if you want to deploy on Kubernetes. And there is a terrific resource called learn.hashicorp.com where you can see the reference architecture for Vault, which I encourage you to do. When you know how you set it up, then you might want to do a little bit of hardening. I already mentioned TLS termination, making sure that the storage is encrypted, making sure local storage is encrypted, after unsealed, making sure that you don't have anything that you might not need there, because it's basically the Go binary. You don't need much, really. You can just run it almost in a scratch container, maybe with CA certificates and a few other things. Then there is like intrusion detection, you have backup and disaster recovery, and so on and so on. Actually, about the log files or audit files, there is a good idea that you stream them somewhere, like on S3 bucket. And if you do so, then you have MFA delete on that bucket, making sure that no one can come in and delete stuff. If someone would come in, and try to tamper with your audit files. Also, what you could do with your audit files is to have a cross-account replication, so making sure your audit files being replicated by Amazon to some other account that current account has no access to, so it's like a black hole. And then you always have a copy if something happens. And you could do much more. There is another resource that you could take a look on. There is a list of what you could do more on top of what I mentioned. Now, when you have like your Vault up and running, there is a like real learning. If you do it via Terraform, you want to split your Terraform spec for the Vault infrastructure and Vault itself. By this, I mean Vault has a Terraform provider, so you can configure Vault with Terraform. And you want to have this one separate from everything else that is needed to bootstrap your Vault, like your ELB instances, databases, what have you, DNS names, and so on and so on. And the reason is that if you do rotation via Terraform of like EC2 instances, you might get yourself into a situation where for a fraction of a second, the instance is unavailable, even like if you use couples. So for instance, the ELB didn't train the instance yet, and your request like at the same time Terraform running the parallel request to the vault itself, and vault is unavailable. And now you're in trouble because then Terraform will stop and you are in a no man's land. So basically your Terraform execution stopped in the middle and you haven't finished rotation and you kind of half configured vault. So like really bad situation to be in. That's why I do recommend you run those specs like at least on a weekly basis to ensure that there are no degradations of configuration. And by I want to say not degradation, but the configuration drift. So there is no drift. That is how you intended to be, and that's important. If there is intrusion, you actually want to know that it is how you intended to be, and that's why you want to run it often, at least weekly. But then do those two specs and do them on a separate days to make sure that they don't interfere with each other. All right, so you got Vault up and running. What is next? You in your command line, you will need to set up Vault other environment variable to point where the Vault is. You will need to have a Vault token, and this is what lets you to communicate with Vault and do things. And by default, when you initialize Vault, you will get root token. It's like a God mode. You can do anything you like. And I suggest you use it once to configure policy and other auth providers so you can get the normal token and then use that one only. And then after that, you revoke the root token because, people cannot steal from you something that you don't have. And root token is the worst thing to lose. And if you don't have a root token, no one can steal it from you. If you really, really need one, after all, if you take those keys I've been talking about before when you initialize Vault, you can use those to generate a new root token if you really, really need it. But in my practice, you only need it once in the beginning. And like if stuff really goes badly, then you might need one in case of some bad misconfiguration, but probably not. And this is like one slide Vault intro that I usually use to explain people how it works. So on the left here, you have auth methods. So you could use different identity providers to come to Vault and exchange your credentials to Vault token that will get the Vault policies attached. And that will allow this Vault token to interact with secret engines. So for instance, those are just examples. There are much more, will allow you to get the lease, and that's in Vault terms is a temporary credential. But you also can have like static credentials, key value store. You could have like encryption as a service. You can have a PKI infrastructure provided by the Vault, and on top of that, you have audit device. Well, in this picture below, you have the audit device that records everything that's going on. And this is how token gonna look like. You're gonna have your token ID right here, and that's what Vault needs to let you do stuff. You will have TTL, so you have issue time, and you know when it's gonna expire. So like that's expiration time. And you can see that's quite short-lived tokens, like valid for only 1 hour, which is good. If it's being leaked, the attacker will have a very limited opportunity to exploit that one. Or am I being wrong? It looks like 1 hour only. All right, so now we are moving on the auth methods and policies because you need those to get the normal token. So I suggest you start with those, and they're boring, hard, but well, they're important. They will allow you to skip using root token. There are a lot of possible auth methods you can use, and the list is growing. So what you and another thing is that you might need more than one. So you might need to have one for humans, and then other for your CI/CD, for your application, for your infrastructure. Where possible, it's a good idea to use MFA for humans, which is kind of obvious, but not always and not for everyone, apparently. So this is how it works. You get auth, you get Vault role, and then you get token with a policy. And I'm going to use LDAP as an example because LDAP is a commonly used thing, and most of the people understand LDAP. I'll just skip this slide. So here's LDAP. configuration in Terraform. I'm still kind of using the Terraform 11 syntaxes here, but if you want to have Terraform 12, you basically remove quotes, $sign, and curly brackets, and you get Terraform 12. So it's quite simple. If you ever configured LDAP connection in any application like Jenkins or anything else, you will know what it is. So you have your LDAP server, you get your users that you use to connect to LDAP, you get your LDAP user password to look up stuff, and then you have like a group filter. That's a backend. Well, LDAP role, and it's just called backend group in Vault, and that will map LDAP policy, LDAP group to the Vault policy. And as you can see here, they're called the same for simplicity. So basically, if the person who came in from LDAP and authenticates, and he is a part of the group called DBA, he will get a token with the policy DBA attached. And you don't have to call them the same, but it's kind of makes it easier for everyone. And here we have like Vault policy document. I do not really go into details in this presentation about Vault policies because that's a talk on its own. So you just can access all secrets here actually, and do whatever you like with that. Again, so you need to have a policy to manage policy. That's not always obvious from the beginning. That's why you use the root token first, but then you want to create a policy that would allow you to manage other policies and to have a way to get this policy attached to a token. So you need to figure out that, and that's quite straightforward, but it's important to be known. The policies are denied by default, so you need to explicitly allow stuff to happen. You don't really have to match all the group name, but it's easier for users if it does, because then they know, like, I'm in a DBA LDAP group, most probably will get DBA policy. And if you are a member of the multiple groups, you get multiple policies. It's straightforward. You could also limit what you could do. So for instance, you could tell Vault through Terraform not to attach default policy. You can limit from where you can kind of get this token from. So like for you, if you have your organization CIDR, your local network, you can say users only can come from those CIDRs. Don't allow people from outside this network get the token. And you can set TTL and max TTL. So the token TTL is for how long token gonna live, but you can renew token if you need it longer. So you could set token max TTL to make sure that people don't keep it forever. Well, up role is if you really have to, and that's mostly used for CI, which is outside of your infrastructure. So like if you're using some SaaS offering that need to come in and get some secrets, like, Circle CI, for instance. Up role thingy is pretty much username and password. So this is how you create it. You create a backend, house backend. Then you create a backend role, and again, backend role allows you to map something to the policy. So you have like a role that will get those policies. In this way, we actually like creating the role because we don't have anything external coming in like LDAP group. And then you want to get your username and password. And this is how you do it from CLI. So you get the role ID, and that's your username, and then you get a secret ID, that's your password. But you don't have to do it through the command line. You could do that via Terraform, so you use this resource, and then you can store it to KV in Vault and fetch it from the KV, or some automated workload can fetch it from the KV if it's already have a token that allows accessing it. Well, then something that is more handy and more secure is because the up role is basically no audit in a good way. Since again, like everyone can get the username and password and use it. Here you're using some, for instance, Cloud IAM or Kubernetes service accounts to authorize in Vault and get a token. And that's very good for your workloads, basically. Here we are using AWS IAM, and you have the backend. You say it's type AWS, and here we have CI Builder as an example, which will be authorizing using his IAM role, and he will get the token which is valid for 1 hour, and that's the maximum lifespan of this token, and he will get this policy. Plus, we limiting who can get token using this one. So we're saying we're expecting the entity that comes in to authorize with this role ARM. And then Vault will need to have its own set of AWS credentials to communicate with AWS and validate the information it receives. So that's why we're creating the IAM user, we're creating the access key for it, we're creating the policy that will allow the Vault to look up users. That's a policy. Then we're creating our backend client where we will pass the key, AWS key. So that's the entity that's used by Vault to look up information in IAM. For Kubernetes, well, I actually have a separate talk how you can integrate Vault and Kubernetes. You might want to go and check this out, and I'm not gonna go into details in this presentation. So now you have a token. What do you do next? Now you get to use the secret engines, and you see there are quite many of them. I took a screenshot from the Vault web page, and there are more actually. So it's like it's only what fit into my screen. So you could get a dynamic secret or actually static, which will, well, dynamic secret's going to have a limited lifetime. It prevents a sharing of secrets. And as I said, you have a break glass procedure and a really great audit of things. And we start with a KV, and KV is a straightforward. It's a static secret. It's storage. So KV, keys and values. You probably want to have 2 of them. So you want to have one for humans to come in and drop some stuff that you cannot generate or fetch from somewhere else. Like, for instance, your SSL certificate that you buy from your registrar, right? You can generate this one automatically, and you need to store it somewhere. And the KV will be a good place, unless you're using the PKI capability offered by Vault. And then you might want to have machine-initiated storage. So by this, I mean, humans are messy, they not always follow structure, and they might do mistakes. So what you want to do is you want to have those humans-initiated KVs as a source that you can read using Terraform, and then basically grab whatever you need and put it via Terraform into another KV that will have predictable and repeatable structure, and no one goes in there and touches by hand. So that's why your applications, when you read stuff from Vault, they will always get what they should, and there will be no surprises. So I do recommend you doing something like this. And here is a configuration for the AWS secret engine. So technically, you could get the same with STS somewhat, but if you do hybrid cloud, you might want to use Vault to, to encapsulate all the interfaces behind it and be a single interface for your developers and automation tools. So what we do here, we're creating the user. Again, the Vault will need to have a user to go in and issue your temporary credentials. So we're creating the user, we're creating the key, we're creating the policy. And here you will have documentation on what policy should contain. Then we're creating the secret backend. So we were creating out backends before, now we're creating secret backends. And what we are saying is that it's going to be AWS type, well, and then, no, that's a pass actually. And we in this region, so the keys that we're going to use, that default TTL. So like it just says 8 hours, and that's 24 hours basically. And that's might be used for developers when they come in, and usually don't. It's quite hard to do 8 hours of productive work when you're actually like working, not sitting in meetings. And 8 hours might be just fine. If not, you just get a new one. And here you have the role, and that's like the admin role. So like with this one, you will get admin credentials, basically, which I do not recommend, but for simplicity of this demo, we're giving like a pre-configured policy of system administrator. And here we have attached. It's a trust document, and eventually you will just do vault write, blah, 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 and TTL 60, and you will get something like this. So you can configure TTL from the command line as well. Otherwise, you will get something that vault configured. And you're getting your access key, you're getting secret key and security token. You get 3 instead of 2 because it's STS based. So you're assuming the role. You're not getting the new user. Vault can create new users for you. In some cases, you need an actual user with actual keys. And in that sense, it will create a user, and when your token is revoked, it will delete the user. Or you can revoke the lease only. This is a really neat way that you could use your temporary AWS credentials to sign in the AWS console without no SSO. So you can, using this one, you could generate signed links that you just paste in your browser and you automatically logged in as a role. Very neat. And this is a presentation from the last year HashiConf in Europe. I do recommend you watching this one because they did a lot of tooling around Vault, and there are a lot of good ideas about what you could do with it. I actually took this idea I showed you before from this talk. I implemented it for the client, and they're still using it today, and it's working really well. So in that sense, we don't have any static accounts for users, for humans, but at all. Everything is dynamic. So database credentials are kind of complicated. So in order to configure, the way it works is, I don't have a Terraform for this one, otherwise presentation gets too long. But the thing is, like you give the vault your root database username, root database password, and revocation, creation, and renewal statements that will be used for creating the temporary users and then revoking them. And those are really complicated. You will need to have someone like DBA with you, like science. What happens is when you get the temporary credentials from Vault, it will create a temporary user in your database with a temporary password. You give it to your workload comes in, creates something like a table, but then when you want to delete that temporary user, you cannot because you have a dependency. The user owns the table. So your revocation statement should be very smart. It should go in and transfer the ownership of all possible objects that could be created by the temporary user to some other entity. And getting that right is hard. There is a hope, though. In Vault 1.2, they added static roles, and that will basically you will have a static user in database, which will have a static username, and Vault will just rotate the password for him, for that user, like constantly, and the password will have a TTL, and workloads will be able to get a new password from it. So might be a possibility to work this around, because then you don't need to revoke, right? So you could, in AWS, you could use RDS IAMouse, and then instead of the password, you will have like a pre-signed token. But still, you have a problem with audit in there, because the signing of the token is a local operation, and in your database log, you will only see that the pre-configured user logged in, but you have no idea who is behind. I spoke to the AWS people. They're saying that they're working on making this more visible in the CloudTrail, but at the moment you don't have any audit, so you'll have to build something else. So yeah, so that's not simple really. And actually, like at the moment, it looks like the Vault is the only solution you have. And then I told you that you give your root password to Vault, which means that you might want to rotate that one. So the Vault is the only thing that knows it. And this is a little bit of shell for you that you could use to go in and rotate it everywhere. And you see, like in the end, we calling the Vault API to rotate the root password. But with this, you're gonna have a problem. So imagine that you have a vault, and it should say like the vault here, not the AWS RDS. And in the vault, you would store your root password in a KV, right? Then you fetch it in Terraform, and then use this password to configure RDS. First time it works, but then when the vault starts to rotate the root password, the password that Terraform has and the password you have here in KV, they are obsolete. So in most cases it will work, but if Terraform will have to change this database, so by default it just reads it, and if nothing changed, it will not attempt to change it. But if it did change, it will attempt to change it with the old password, and that will not work. So you will run into problem with your automation. I have an idea that you might be able to create a static role for your root, and then you will be able to fetch it from Vault, theoretically. I haven't tested that. Another option is to use AWS Secret Manager, and that one can also rotate the root password for RDS instances, and it also has a possibility to read the password. So you have like the one source here, and then Terraform fetches from here and will configure the RDS. You're not using Vault in this way, but you kind of have a secret sprawl, but the Vault, the Vault workflow with Terraform needs a little bit of oiling, I would say here, a little bit of oil so it goes more smoother. But it might be able to work out with static roles, maybe, because Vault by default doesn't allow you to fetch the root password when you gave it to him. But if you create a static role for the root, maybe you can do that. So other secrets rotation. Then you saw we created the keys for Vault, and you want to rotate those as well. Vault has API for that, but again, if you use that API, Terraform gets all confused. Since from Terraform perspective, the key it created just got deleted, and it's not aware that Vault created a new key, and then Terraform will create one more key. Next time you run it, again, the key is not here. I'm going to create one more, and the number of keys you have is growing, and by default, AWS has a limitation that user can have only 2, so you will run into Vault quite quickly. That's why I do recommend you run something like this. You're basically tainting the Terraform resources, and next time you run Terraform apply, they will be deleted and recreated automatically. Well, some unexpected findings, and Terraform provider for Vault, in some cases, which I cannot point down, but it looks like when you create a KV, it's all fine, Terraform reads it, but then when you go in and by hand add additional items in there, Terraform not always refreshes, it not always rereads the KV. And then you might want to go and remove it from state, like doing like this Terraform state rm data source, in order to force Terraform to reread the KV. I had developers coming in and saying like, I'm running Terraform, I can see the new item in Vault, I can read it using the command line, but Terraform cannot get it. What's going on? And the solution was to run Terraform state rm. And I see that on Terraform 11. I'm not sure about Terraform 12. Terraform 12 might act differently, so cannot tell. Final thoughts. Vault introduction into any company is a journey. It takes some time, so start small. Find the use case that will bring the biggest benefit for the company and implement that one first, and then build on top of that one after another. It gives you Vault gives you a great foundation for building, a security first platform for your developers. Like if you have Vault from the day one, then your developers don't need to take shortcuts when it comes to security, and they're building security into their application. And it's really hard to add it on top afterwards. Doing the Voltus code is the most safe way available, so do that. Do that as code, and it will help you a lot. As you could saw, that there is some glue needed here and there, but it's getting really good. Like in 2018, there was like nothing available, and then HashiCorp did a really good push across 2018, 2019 to get Vault provided for Terraform on a really good level. So today you could do almost anything you want. You have some fringe cases, as I showed you, but in most cases it's just fine. And yeah, reuse and share when and where possible. Like obviously security is a sensitive topic, but there are still a lot of things that's possible to share. And like as we all learning, as we all sharing, we're getting more secure. And this is how we want the internet, right? We don't want to have all those data breaches going on all the time. We want to build a safe software for people to use. And yeah, there is still need for best practices. That's why we got to keep learning and keep sharing. With that, we arrive to the final slides of my presentation. I say thank you for listening. If you have any questions, that's the time for them.
Hi, and thank you, Andrey. Thanks for joining us. We are just waiting for questions in the
It
live
was a
chat.
great talk.
Right.
Andrew, we'll just wait for 1 or 2 minutes for the questions, and we will go with the
Yeah,
questions.
sure. I'm gonna drop my sharing. So
Yeah. In the meantime, we have our next speaker, Amitosh. Amitosh, you can start sharing your screen.
Yeah, hello everyone.
well, I guess people might have one question: is how do I get slides? I'm gonna export them as PDF and drop them to the meetup user group, so you will be able to download them from there.
If possible, we can add it in the YouTube live chat as well, the URL to download.
Okay. Yeah, then you can link the meetup group from the
Okay,
YouTube.
no
So,
problem. Yeah, sure.
well, sounds like no questions.
Okay, Andrew, like if we find any questions, you can feel free to answer them in the chat itself, in the live chat.
Right, I might dropping off soon, but
Okay.
people can write the questions on the meetup.com and your meetup group, and then I will follow up there.
Okay. Thanks, Andrew,
All right.
joining. Like, looking forward for your talk in HashiConf Digital. So, all the best for the talk.
Thank you. Thank you. Thank you, guys.
See you, Andrew.
I think Amitosh, you can go ahead. The screen is
You
being
can start.
shared. Yeah.
Yeah. Hey, hello everyone. Myself Amitosh here. I'm like like we are here today. I'll be discussing about Envoy. It's a nice proxy. It's a proxy that you can use with your cloud native compute for like applications that you are running around. So, hey, am I audible?
Yes, you are.
Okay. Okay. So, yeah. So this is about myself. Like I work in the GoPay team at Gojek. Like Gojek is a super app of Southeast Asia. We have stuff regarding from transport to food to. I mean, most recently we're coming up with a OTT video platform as well. Like we have lots of things, and we use Envoy a lot. So that's what I'm going to share. Some of my experiences while working over Envoy at my job, as well as some of my own, you know. Uh, more adventures that I've done at Envoy. So I contribute to open source. I'm part of Fedora Foundation, like Fedora, and I contributed some stuff at Elastic. I mean, I still do at like also at Fast Foundation as well. You can find me anywhere at Agathware, like I'm on GitHub and Twitter. So that's all about me. So today here we are about to discuss about what is Envoy and why do I term it as programmable proxy, and how it can help you, like how it can work as a load balancer, as a proxy, and how can you use it with Kubernetes, or like how can you monitor your connections. So this is all about, I mean, I guess most of you who have worked with some kind of like software which you have designed to be scaled will be using some proxy software like maybe Kong or Nginx, or like you might be using directly AWS ELB, or like Google's load balancers. And here I'll be mostly talking about how Envoy differs from all the others. So this is what the most like the primary focus of my talk would be about. Yeah. So let's get started. Now Envoy was created by Lyft, and they donated it to CNCF, and now it has graduated to a like full CNCF project. Now primarily it's a open source level 4, that is your like IP layer, and layer 7, that is your application layer proxy. Now it is fully programmable. You can monitor it as you want, and it supports many protocols like HTTP, MongoDB, Postgres, like gRPC, or you can just drop down to L4 and proxy TCP and UDP protocol if you like. And the best part of it is that it has a plugin architecture which allows you to extend it in many awesome ways. Now what do I mean when I call it as a programmable proxy? Now Envoy is fully controllable by APIs. Now Envoy exposes something called as an XDS interface, which I'll be talking about in the next few slides, which all the configuration can be fetched dynamically. Now you can say, hey, establish a cluster from like a pool of resources running behind a like Kubernetes deployment, or you can say, hey, like establish a cluster and load balance them among something that is running on a group of VMs that are being backed by console. So you can do all of this using those XDS APIs. Now, if you're looking for something static, then you can also put in files, and also you can mix and match them. But the API style configuration is what that makes it very very attractive for using with dynamic environments. Like you have pods that are coming up and going down. You have auto scaling VMs, and so you don't have to go and manually edit files. I mean, just expose something that exports the state of your current infrastructure, and make Envoy read those configuration using one of those XDS APIs, and you will be having a fully dynamic environment, an API gateway or a load balancer, however you want to use it, in no time. And still, if it doesn't suit you, then you're free to write a Lua or C++ filter and compile Envoy with it. So I was talking about XDS. So this is XDS. So X is basically of 7 things. We have CDS, that is for discovering clusters. Like cluster is a group of servers that does a single thing. A cluster can be a cluster of your application, cluster of Redis, cluster of anything. Endpoint is EDS, which is defined by like what is the health of the cluster, like can the cluster accept, like what is the state of the cluster, can the cluster accept the current request, or what is the IP address where I need to put it. And then you have RDS, basically it's for creating URL routing routes. Then you have LDS, which says, hey, listen on port 8080 or 8081 or something. And you have SDS, which I really love the most, but it is for fetching dynamic secrets such as your SSL certificates, your client SSL auth, and you can bridge it to something like a Vault provider, like you store your certificate inside Vault and you stream it from Vault and use it directly in Envoy. You don't need to write it in any disk or something, and it's quite much more secure. And you have health discovery, like if you don't want Envoy to do health checks, or you have something else like Kubernetes or console that already does health check for you, you can get those data and still decide whether to send some request to a particular endpoint or not. And if you want something which combines all the 6 XDS information, you can use something called as an ADS service, which basically takes in all the information and aggregates them, hence the name ADS, and does all kinds of interesting logic-based decision making you want to do using ADS. So here are the thing that Envoy can do for you. Like you can use it as an ingress proxy. I mean, your like most typical example, like you put it in front of your incoming traffic, and you control everything that flows in and out of it. And you can do authentication and authorization. You can have some sort of rate limiting and all at a single place. Like that's one of the uses. And one of the second uses is like egress proxy, where you control all the traffic that flows outside your cluster. Like you will have some applications that need to call a third-party service. Maybe you have to call some payment gateway, or you need to call some like some storage provider or something, and you want to control who is having that access, or maybe the external party will have some kind of difficult mutual authentication scheme that you don't want to put everywhere across all your applications. You can have that thing taken care of in Envoy as well. And load balancer, like this was what Envoy was originally designed for, so it works at a quite smart load balancer, supports a lot of load balancing algorithms, and also like you can configure it to be very adaptive. Also, another interesting use case that have come up since last year is using it to monitor traffic. Like as we'll see, like I have an example later about how do I use Envoy to monitor Postgres and Redis statistics about how they are being used by my application. So that is one. Now this is about how Envoy, you can use it as a load balancer. Now using the CDS, EDS and LDS part of the XDS API, you can configure Envoy to be quite a formidable multi-protocol load balancer. Now as I discussed earlier, it supports active health checks. Like you can configure a health check endpoint, it polls it every time and sees, okay, this pod is up, this pod is down, I'll send traffic here and there. And also it allows you to export traffic in HTTP2 if your pods are not HTTP1, so it does the transcoding for you. So I mean, if you're running some old struts based like microservice, let's say it's a quite legacy stuff, and you just want to speed it up by using HTTP2, then just put in Envoy in front of it. All your applications use HTTP2, but you still have HTTP1 out there. Not only HTTP, you can proxy MongoDB, you can proxy Postgres, you can proxy Redis, and also if you are having any application protocol that runs in something like on a TCP or UDP, which you can basically load balance by splitting it up in the layer 4 of the network, then you can also do it in Envoy. Like I know some people who like use the recent UDP proxy support, and they just load balance a UDP service. So it's some custom service that they do. So I mean, you can do that as well, or you can put it in front of a statsd server and you do for high availability. So that is also some people that have done, I know. So you can configure, like since it can act in both ingress and egress, so you can put it as a server-side LB or as a client-side LB. So it works fine as both. Yeah. So next one is how are we using Envoy as a proxy? Yeah, it does convert your HTTP versions from 1 to 2 or 2 to 1, however you want. And also, if you are sold in with gRPC, like we have, then you have certainly some client coming, hey, we don't understand gRPC. Then you don't need to write a complete gRPC gateway for it. You can use Envoy to do like trivial transcoding between JSON gRPC to like the internal gRPC services. Like you have your call coming in as a REST API call or a like JSON API call to your Envoy does transcoding into your gRPC call, and your gRPC service returns you with a gRPC response, and response again get transcoded back and get returned as a JSON response. So if you have like if you're in middle of migration from JSON to like gRPC, like Gojek was about like a year ago, and I mean, there are still services which are. So this is a very handy way of dealing with that migration, like keeping your legacy interface intact as well as like having using gRPC for the modern ones. Then you can do TLS termination. You can do rate limiting, you can do authentication, like you can connect it to an OPA running somewhere, or you can have like write your own authentication. Like there's an API called as authz that Envoy provides you. So if you implement that authz provider, you can write your own rate limiting authentication stuff. So that is something. Then you can put it as a forward proxy. Like I remember a use case where we make call to a payment service provider and they have really complicated encryption stuff built in, and like configuring them like across 10 different applications is not really scalable. So we put one Envoy in front of it and that it handles up everything for us, and our application simply need to call Envoy. And if an application is allowed to call Envoy, it can talk to any services that Envoy has a handshake with. So that is something. Also, there is like we use it for like proxying Redis. Like you want to scale Redis, so your options are quite limited. Like either make a cluster or like just keep on increasing memory, keep on increasing CPU till it becomes too big to manage. And so Redis doesn't do any kind of sharding or stuff, and so Envoy can easily do that. So you can have like partial failures if you want, like half of the shards are down, so that's fine, still half of the application is running. So if you're running some critical infrastructure where at least even if you can run on a degraded version, half of the Redis keys are down, you can still run. So you can have that kind of you can design that kind of architecture using Envoy as a middleman. Also, like I've been talking about it much, like SSL offloading, like you get it from a certificate manager and then configure XDS for it for certificate rotation and all, and Envoy becomes an absolute low maintenance proxy plus TLS termination. Now, I remember a really recent incident where some certificate got expired and everyone was like really crazy about like how to build it up. So like when we had XDS, where like it was all like you just go and rotate the certificates in Vault and everything else gets it. So yeah, then many people are interested to run Envoy as an API gateway. Now you have like LDS and RDS, so you can easily add and remove routes from a dedicated service. Like there used to be something called as a rotor, but currently they got acquired by Slack and they are no more being maintained. So so you have other alternatives here, like you have Glue, you have Ambassador, you have FTO. So you can like they are basically like now wrappers that have been built around Envoy. So they have their own plugins, they have some custom code that allows you to use Envoy as a like bit more fancy API gateway. Like you put allow list, you put block list, you put you put traffic rules, you put authorization using your authz and OPA or like your custom backend, and you can have your rate limits that basically talk to again using the authz protocol, and you can handle all of this at one place. So when you're actually exporting something that has been consumed by other third parties, having an API gateway actually really helps you. Like you can control whether someone is able to access a particular stuff, or you can do traffic sweeping, and you can do all this kind of fancy things out there. So this is an interesting use case of Envoy. Like it's been a bit popularized from last 1 year. Now Envoy by default has a ground up. It was built to be instrumented with statsd, and later on they came up and added Prometheus as well. Now this is something that really differs it from other proxies. Like getting like metrics out of Nginx is really tricky, and with Kong that becomes a bit more simpler, but still it is not as simple as you can get with Envoy. So you have your stuff like active connections, max connections, like success failure per route, per cluster, per like per endpoint and all, and so and whenever you're having some issues with microservices not being able to talk to each other, like the first thing that you should go and like, hey, check your Envoy dashboard, like where it is, what it is happening. Now, for protocols such as MongoDB and Postgres, we have some additional metrics that are available, which are quite valuable. Like you can easily do query timing instrumentations without modifying your server or your application code. Now, you can also get like query sizes, how long or who is making lots of queries, like what are the kind of queries that are making, or you can like by using this capability of Envoy, you don't have to actually put monitoring agents, like database, which kind of make it slow by reading, making so much database queries and all. So you can have all this nice stuff out of Envoy itself. You don't need anything. Yeah. Now, using Envoy, if you're having a Kubernetes like environment, then it becomes also quite easier. Like you have your Envoy help chat, or you can use something like a Glue or Heptio controller that really simplifies Envoy management. Like you can define your Envoy rules as resource definitions itself in your deployment. Or if you are going into full service mesh, then you have Console Connect or you have Istio, which basically use Envoy as a sidecar. They inject the sidecar in your like application. Then you are free to just talk to the Envoy itself. Like you don't have to talk anyone else. Just talk to the Envoy, and Envoy handles everything like circuit breaking, rate limiting, authentication, trust, and all of them is taken care by you. So, or else you can also use Envoy as a load balancer, which uses your data from Kubernetes. As you know that the Kubernetes native load balancer fails for something like gRPC, and having something like Envoy really helps us because we can still rely on Kube's service discovery, but we don't have to rely on Kube's load balancing. Like Envoy helps there. So that is also one of the way that you can explore this Envoy. And here are some use cases that we have been exploring, like something that I have been working on. And so, as I said earlier, like Istio is a like real nice service mesh that is built ground up using Envoy and Envoy APIs. Now they inject envoys all around, and they provide you complete visibility about what is happening in the network layer of your application. Like you get a nice service map, you get distributed tracing, you get traffic shaping, you get rate limiting, all of them out of the box. And also, if you have some like complicated authentication requirements with some third parties, like they will ask you to encrypt your body with some particular key, you have to rotate keys in every 7 days or a single day. I mean, handling all of that in all your applications that make a call is really, really tricky. So this is where you can easily write as a Lua code or some C++ code, or just simply use stuff from like SDS to do mutual TLS with an external service, or do encryption on the Envoy itself. Like this is a really handy feature. Then I have also used Envoy like at some point, like at a point of time for starting Redis. So I mean, this is like when you are starting using Redis as a Redis as a cluster, you need to make some changes in your application code. And let's say you don't want to do that, or you don't have the source for the application to do that. So just use Envoy as a proxy for Redis. It it abstracts out all the cluster thing from you. So just talk to it as you're talking to a normal Redis server. So also there is a project called Patroni that some of us use. So it allows you to deploy Postgres in a really high availability manner. So Envoy forms the proxy for it. So all the requests, all the queries, they come to Envoy, then it is forwarded to the appropriate Postgres, like whichever is the current leader in our group. And Patroni itself exposes some XDS APIs, and Envoy talks to it and decides where to route request and all based on that information. So as a gRPC API gateway, I mentioned this earlier, like you can expose REST equivalents while your internals are all gRPC. You can do it quite well. And you can do like client and server side load balancing. And let's say you are trying to starting using distributed tracing and you don't want to actually modify your application code, then you can add all these headers from Envoy itself. Like there are Lua plugins that are available that you can plug in, and then you can like start using it. Or Envoy itself gives you a request ID that you can use as a simple form of distributed tracing. But means that's all about it. So it's quite powerful. Like I'll ask everyone, like you can think of your use cases. I mean, Envoy is a lot more than what I could discuss in this few slides. I mean, there are a lot of possibilities. So I mean, every day it's been changing, and they're bringing on new features. So I mean, the project is quite vibrant and dynamic. Uh, so this is all about it. So I'll be open for taking questions. So you can ask a question at this URL if you want, or in the chat. I'll be looking at both.
Okay, great talk. Thank you.
Yeah.
We'll just wait for a couple of minutes for the questions in the live chat. There's already a question there. Are you able to see, or you want me to moderate it?
Uh, um, I'm seeing this question. This is from Nicholas. Is it possible to configure API gateway as well as load balancer functions simultaneously on Envoy? Yeah, it is definitely possible. Like, I mean, that is one of the primary use why we use Envoy as well. Like, I mean, we use it to like control access to APIs as well as perform load balancing simultaneously. You don't need to have multiple Envoy instances. So, I mean, that is quite handy. Yeah.
Okay, then we'll go ahead with the next talk, Amitosh. Like, if you see any questions, like you can directly go into the live chat and answer the questions.
Yeah, I'll be monitoring the chat for a while. So if you want to ask any questions, then yeah, just shoot a request.
Thanks again, Amitosh. Thanks for joining. It was definitely a great talk.
Yeah, thanks for hosting me as well.
Yeah. Harsh, you can start sharing your screen.
Uh,
I'll just
yeah,
pin your
Vineeth.
screen.
Yeah, one second. Okay, one second. Seems to be a problem. For some reason, it's just stuck. Just give me a second. Vineeth, am I audible?
Yeah, you're audible.
Okay, my screen is stuck. Just give me a second. Oh,
Or else, in the worst case, like you can just send me the URL link for the slides. Maybe I'll put the slides. You can talk, or else just take 1 or 2 minutes, restart your system, and come back.
yeah. That I think I'll have to do that. For some reason, I can't even switch windows.
Okay.
Okay. Give me 2 minutes. I'll be back.
Okay.
2 to 5
In the
minutes.
meanwhile, Amitosh has another question. Maybe you can answer it in the call.
Yeah. That will be nice. Yeah.
Yeah, hey Gopal. Yeah, like your question is when should we prefer to use API gateways based on Envoy, such as Ambassador or Glue, over using Envoy itself as a gateway? So the Envoy itself as a as using Envoy itself as a gateway will be a quite hard task for you because Envoy is quite bare bones on its own. Like it's just programmable. So like these projects like Ambassador and Glue, they provided a nice, really nice wrapper over Envoy that helps you in management. So I mean, currently we use our own in-house wrapper. Like we didn't have, like we were quite early adopter of Envoy, so we didn't have ecosystem associated with it. So I mean, if you want to use it as an API gateway, I will strongly recommend use one of those wrappers like API, like Glue or Ambassador. So I hope this answers your question. So if you have any follow up, you can ask me.
Okay, Amitosh. So I have a couple of questions. Like by the time Harsh joins, like I was just thinking, do you guys use Envoy as a proxy separately as well as Istio? So I recently saw a blog post from Gojek describing, like I think It's from one of my friend. I just Tasdic from on how to
Yeah, yeah.
use STO and everything. So Envoy is used as a part of STO or else separately, like other than service mesh also it's being used.
So Istio is basically a very new entrant in our stack. So we're still experimenting on it. So there are some teams which are working with Istio. So when unfortunately Tazik's unit is really separate from me, so I can't talk about how they are using.
Okay. Okay. I just wanted to understand
But
like the knowledge you have Envoy is from service mesh perspective or separately also. Yeah.
no, even our unit also uses Envoy as in both capabilities. Like we have some VMs and we use Envoy to load balance over them,
Oh,
and we have some queue services. And then we during our migration we used to have Envoys as a proxy so that we can switch between pods and VMs. And also we use Envoy as part of Istio as well. So the Istio infrastructure is relatively new. We're still building up and we're experimenting with it. So I mean, you have like 1,000 microservices. You can't just move it overnight. So it's going to take a while.
yeah. Totally agree. Yeah.
Yeah.
Nice. Nancy says, Vineeth, your voice is very less audible.
Ah,
Oh. By the way, belated happy birthday, Amitosh.
yeah. Thanks.
So one other question, like I have never used Envoy, but it definitely creates the curiosity in me. So let's say I have two services right now. We are using gRPC for communication. So if there are two to three different services, will Envoy can do the gRPC load balancing as well, as you mentioned in slides?
Yeah. So we have one central envoy that was used for migration purposes that handles like 23 different gRPC like load balancing. So I mean, it's kind of like it's a cluster of envoys that are there and they do this load balancing for
Okay.
us.
Because that definitely creates a curiosity in me because in gRPC we use the same TCP connection again and again, and we just call it as a method. The HTTP request itself is called as same as a method in one other library. So
Yeah.
so how I so Envoy will have a live TCP connection and it just shares it with all the incoming request.
Yeah, so Envoy, like let's say you have four pods and four pods are handling your gRPC services. So Envoy will keep four TCP connections with them, and let's say you are having 20 different callers, then 20 different callers will open 20 TCP connection Envoy itself. And what Envoy will do is like load balance these 20 connections, like multiplex them on these four different connections. So
Okay.
you don't have like even if like in gRPC your TCP connection is really going to open till the lifetime of your connection. So like this multiplexing happens on Envoy itself. So load is really evenly balanced between your four ports. This is how it works.
And the pool of four pods are maintained based on the health check itself. Like if let's say if some pod is down for some reason, will like if the new pod comes up, so how will that new addition will be added to the Envoy?
So that's why you have this RDS and LDS.
Okay.
So and EDS as well. So like we use a custom in-house wrapper called as console NYXDS. So it was built even before we had Ambassador or we had Console Connect available. So it's from 2016. So you can go and check it on Gojek Tech GitHub. So we use that. So what it does, it basically does a console watch. So whichever VM is down or whichever pod is down, it pulls in all the configuration and like can paste it in Envoy as a routing table, so that if some health like some service is down due to health check, we can stop totally take it out from the pool. But Envoy itself has its own health check. So if you don't want to rely on something like console, or like you want to cordon the pod as soon as it goes into a degraded state, Envoy can do it for you because it has its own active health check.
Okay.
But
Nice.
like, removal is automatic, but addition needs to depend on like XDS APIs.
Okay. Nice. Nice to know that.
Yeah.
Hello.
Yeah, Harsh, I'm able to hear you. Yeah,
Yeah, I'm so sorry.
yeah, no
I'm
problem.
so sorry about all the problems from my side. Yeah,
Yeah, and you can
one
start
second.
sharing, so we'll just see how it works. In the meantime, Amitosh was just accompanying me here, like we were discussing on some more use cases on Envoy.
Nice. Okay, is my screen visible?
I think it seems to be a stuck, like you're presenting your screen, it just says that's it.
Oh, yeah, 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 yeah. Okay, I'll have to.
If you're on video stream, like I think you're already off. Yeah, like you can off the video streaming from your end to be much like to be the internet more fast.
I did. So, is it visible now?
Yes, like it seems blank screen like docs.google.com. Yeah, it's now visible. Yeah, you can go
Okay,
ahead.
there's a lag. Yes. Yeah. Hello everyone. My name is Ash, and today I've been facing a lot of issues. Uh, Moving on. So currently, I'm interning at CNCF through Community Bridge, contributing to OpenEBS. It's a storage project. I'm also a HashiCorp ambassador. I organize meetups at HashiCorp user group. I'm a huge serverless enthusiast, so please, I'll feel free to talk about anything related to serverless or Kubernetes. So today's agenda is quite simple. So uh, why do we need to use gRPC? We have been building APIs from past 2 decades with REST, and it seems to be working fine, right? So why do we really need gRPC? So what's wrong with REST? Uh, we'll look at that, and then I'll walk you through the code of simple primer of how gRPC helps us build APIs. And then we'll look at the advantages of building APIs in gRPC. And feel free to ask questions in the chat anytime. So I want you guys to take a moment and think about how do we really build APIs. When we want to build an API, how do we start? So if you take a moment, you realize that, I mean, of course, I'm talking about REST APIs here. So you would either start by writing code itself, or use a tool like Swagger to first write the spec of the code. So first, moving a little back and looking at what actually REST is. It is just an architectural pattern. Uh, like we have a URI path which defines what the structure of the HTTP methods would be. So we have verbs which define like what you want to do, and usually we just stick to the using JSON. I mean, of course, you can use binary and XML or whatever you want, but the data format is usually JSON because it's easier for human eyes. So we have been using it for 2 decades. So why is this good? I mean, there must be something that is good. That is the reason we are using it. So the text-based protocol is easy to understand. There's good tooling available. A lot of frameworks already have support for this. It's rich here right now. There might be a lot of other reasons, but moving on, we'll look at the problems. So writing client libraries is not really fun uh, in one language itself, let alone in different languages. When you develop an API, people from different teams expect different languages, client libraries, and that is really hard. And we also uh, screw up naming conventions. Take an example of AWS. Over there, even the three APIs have different naming conventions across languages. So it really gets complicated. And documentation, it can feel short depending on the way you do it. And it's difficult. We can use scripts, but mostly the implementation is upon us, and it doesn't support bidirectional streaming as well. So, and RESTful doesn't always make sense. So when you send a GET request to something, you don't always fetch something back. Get request might be doing something behind the scenes to, I don't know. And we can do better data serialization than text. JSON is basically a text format. We are sending text over wire, and computers are not a huge fan of it, performance wise. So when you think about this, there are actually really three simple steps to building an API, the building blocks. Of course, a lot goes on later, but you look at implementation. Uh, I mean, when you start writing code, and then you document that code for use with Swagger or something else, and then you use client libraries. Now, based on how you do it, you might document with Swagger first and then implement, but the core concept remains same. You use these three things. So with gRPC, we do something similar but quite different. So let me just show you instead of speaking about it. Is my screen visible, Vinny? Hello. I'm still there, right? So assuming you guys can hear me. So we start by defining a proto file. Now this proto file, we have all the necessary machine readable contract ready with this. It is pretty simple to write. So in gRPC we have something known as protobuf, which is a pluggable interface. We don't use JSON here. So a little bit about what protobuf looks like. So over wire we send this, like we send binary over the wire. Like if you take a look, int is 8 and 96 is a letter and 1 is 1. I hope that makes sense. So we define this protobuf. There are two formats actually, syntax, proto 2 and proto 3. You don't really need to use proto 2 if you are writing a new API. It is just that Google has made it for their internal purposes, and then when they open sourced it, they stuck with proto 2. So what is gRPC? Before I just show that. It is a high performance open source universal RPC framework. That is what the docs say. So looking at, coming back to the demo again. So we define this message. Let's keep it intentionally empty because like we can just send a request without any parameters in it. So I have the service welcome, and it has a RPC method which takes an empty message type, which is like I mentioned here, empty, and it returns person. Now what is this person? Now this person message can have a string, and you can have various data types over here. You can like have an int or something else as well. But what needs to be kept in mind is you need to change the number at the end. So this will always be an integer over the right hand side. This is what the binary representation would be. So this always needs to be unique, and it is suggested not to change that number to have backwards compatibility, but you can always add in fields. So with this we can generate both server side code and client side code. That is the most nice fact about gRPC. So if you take a look, you can, there's a proto-C compiler which compiles and generates both the client side and server side code. So there's a server stuff which has interfaces, and you can then just implement the interface. So I create a makefile not to type every time I want to compile that. So I have written this makefile for that. And what it does is, if I just show you, So there's this warning, you can just ignore it for now. And what it really does is have this, it generates huge code, and this is recommended not to edit and everything else. So you are not supposed to touch this. People can generate it from their end if they have this prototype. So it has a lot of things, but what we are looking forward for is an interface which we can use. So if I can just find it. I think it's a small line if it matters. Just close this. Yeah, so this is the interface we are looking for. So we need to implement this interface or this method in the interface. So I have done that. So right now the is pretty simple. It takes and returns person's name, right? So let's look. This is the server. Yeah. So this is the second example. Just give me a second.
I think Harsh, your screen is freezed. Like I see it, but I'm not sure. Like, yeah, the screen seems to be freezed. Now it works. Yeah.
Oh, okay. Uh,
Okay, go ahead. Go ahead.
okay, I think there's a delay.
Yeah, yeah, go ahead. Yeah, it works now.
So start. If you're familiar with Golang, I mean, it was just complaints if you don't use it. So I've just initialized a logger, and we start with a gRPC. I mean, we create an instance of the new server, which you can then register. So okay, right. So this is what I've imported. The generated code over here, pb.go, is what is being imported over here with Protos. So after that, we to have so if you just those dot, and you will find that you can register welcome server and the name of the service. You need to register the name of this. So that's what I have done here. And this complaint is because I have not really implemented the method yet. So we'll talk about this reflection and everything. So and similar to listening with red.listen, we can just open up a port and listen the gRPC server. That makes sense. So I've created an empty struct. Here you can have your logger or something and anything else, and then you can even have a constructor which passes the instance to this server. But this struct needs to have a method. This method is over here. Just comment the right path. Yeah. So I have this method for this struct which says that the function signature satisfies the one which over here, which is done by error.pv.go. That, yeah. This is what the function signature is. I can show you here. And if I have the screen again, yeah, you can see that, right? So we have world, and so I had to name the variables and do some sort of other stuff to make it work in Go's context. But I have the method. So I have this name variable which says that CNCF and user group. So if you can notice, this person is what we have been returning, right? So we have mentioned that we return a person, and this person is in a protobuf message type. Now this is converted to a struct automatically by Go's compiler, ProtoC's compiler. So the struct looks something like this, if you can see, or I can just go to the definition and show you. So we have the struct. This is the internal field of protobuf, but mainly we have this name field which is useful for us. So you can even see struct tags like protobuf, and you even have JSON for human readability. We'll look at how we can read JSON for testing purposes. But mostly when you're going for production or something like that, actual use case, you would use protobuf. So, and we have this import as proto for null, which doesn't have any field, which was intentional. So we just return the struct with a name field as in it, and the error is null. So let's see how it works. Okay, might have not commented something. Let me just come. So you can see that I've started listening at port 1990. Now accessing this API is tricky because, like I said, protobuf is it's a binary. So when you access API, you get a response in binary. But you would ideally want, while testing to have a text format for readability purposes, or else you wouldn't be able to test it easily. So there's this amazing tool known as gRPC. So grab out master, typing it again. Just zoom in, and you can see. So this gRPC curl is pretty simple to use. Let me just walk you through it before I. So we have to use a plain text flag, or else it doesn't work because gRPC actually expects you to use text and your user. So by using plain text, we disable the TLS auth, and what you can do is when you do list, you can have available. This is possible because we are using .txt or
I think we lost Harsh. We will just wait for 1 or 2 minutes. I'm not hoping it's a power cut. But in the meantime, if someone has any questions on gRPC, they can put it in live chat. So I'll try answering few questions.
Am I audible?
Yeah, you're audible.
Okay, sorry, I got disconnected, I guess. Uh, where did I lose an idea?
Even I'm not sure.
Okay.
Yeah, you can just
Okay,
continue
let me
with
just
that
see the chat.
gRPC curl thing. I was last remember there. So yeah.
Okay, okay, sure. So I was showing how to use gRPC curl. So you need to have the reflection key enabled
I don't think we
to
are
access
able
the
to see your
services.
screen.
I mean,
We are unable to see. Okay, you're presenting,
oh, okay.
but why is it we can't see your screen?
Still, still not visible.
No,
Okay. Uh,
I don't think you're sharing the screen.
okay, check again. Oh, okay. I actually did. I don't know. It got disconnected, I guess. Is it visible now?
Yeah.
Okay, great. So again, like I mentioned, this is like robots.txt for gRPC. So like this is available, and we can what we have. Like welcome service has world method, so we can just check that. And let's call this method, and we have what we expected, a simple method which takes nothing and returns a parameter, string parameter, right? So let's look at the client side code for this, because one of the lovely things about PC is that you get the client side code. So why not use that? Let me just come this. So again, pretty simple. So again, as I like this is how you create a connection with the server. So you can create long-lasting connections with the server, right? And you need to have them with NCF flag because you're not using TLS. And by default, the whole gRPC framework expects you to use TLS. So since we're not using it, we use with NCF. This is, I mean, for just playing around, you can use this. So again, idiomatic code. We close the connection before we can use refer and close the connection. So what you can do now is you can create a client directly, because this is what gRPC allows us to do. You can just have a photos.welcome client. Like when you do, you
Harsh,
like
like
you have the client already.
I think you have a
Yeah.
problem with your mission. Like your screen sharing is getting automatically terminated, and even now it got terminated. Maybe like
Oh, okay.
I
That's
think your CPU fan sounds comes till my ear. I do not know, like it's getting exhausted
oh,
or
okay,
something.
okay.
Yeah, but I think like there were a couple of screen freezing as well before. So
Yeah, yeah,
maybe like you can try once more, or if not, like you just share your slides or your project
yeah, yeah.
into
Okay,
push it into GitHub and let people know because yeah, because we are like running out of time. Like we have 20 more minutes. Yeah, like
okay, okay.
if you can share, like we can definitely extend it to like more time, but it's getting terminated. That's the thing.
Yeah, yeah, yeah. Okay, I understand. Okay.
I am pinning your screen again, but okay, it says you're sharing the screen, but I don't see anything.
Okay. Still nothing?
No, I don't see anything. Like it just says presentation Harsh Thakur. That's it.
Okay. Uh,
I think you're having a really bad day with your system.
so yeah, exactly. Uh, hmm, I'm thinking what we can do. Uh, can you show the slides so I can just briefly talk over?
Yeah, sure. Like Just send me the slides link in the chat, in the meets chat.
Yeah, that's okay. Yeah, I got it. Take this. Okay, I think you won't be able to see. 1 second.
No, you should be giving me the shareable link, like view access to anyone or something like that.
Yeah, got it.
Or
Yeah,
else I should
got
request
it, got it.
access and
1 second.
allow.
Yeah, got it. I'll send you the shareable link. Okay, okay, try this.
It works.
Wait, I'll stop presenting now. Okay, so mostly my talk was based on demo, but sadly, uh,
So I think from
I'm
here,
having hard luck.
from here,
You need to share your screen.
okay. People like viewers from YouTube can see my screen, but you can't see it. I understand.
Oh,
Uh,
okay, okay.
yeah, sure.
1 second, I'll just tune in to the YouTube stream.
No, it will be a bit delay. It's like you can't cope with that. So you can see, you are seeing
Okay,
me,
okay.
right?
I got it on Google Meet. I
Yeah,
got it on Meet itself.
yeah. Go ahead.
So, I think what we can do is, if you can, I can just brief over the GitHub code, if possible. I think it's in the last references.
Or else I would
Last.
suggest like to go through the slides first. Like you have three or four more slides. So yeah,
Okay,
then we can switch to the GitHub or anywhere.
okay, fine.
Yeah.
So, move on to the next slide. So with gRPC, with gRPC we define the services first, like I was showing in the proto file, and we generate client libraries in more than 10 languages. You can depend. I mean, the proto C compiler can have can generate code in more than 10 languages, and you can have server stubs with which you can create the service and then register the service to the gRPC server, which I was showing. And one of another best part is the protobuf is actually pluggable, so you actually don't need to use protobuf. You can even use XML or JSON, but it is the most, I mean, there's no reason you would want to leave protobuf because uh, it has better data serialization. So I've seen the benchmarks and it is 10 times or 8 times better than JSON itself because it is in binary. And streaming is pretty easy with gRPC. You can even have bidirectional streaming. So for chat services or something which requires long-lived connections and data to and fro at a fast rate, streaming is really a nice feature to have. Vineeth, can you change that? Yeah. So you might think, why not just stick to Swagger, because we have the machine readable contract with Swagger and we get client libraries with it too, right? So with Swagger, you're still limited to HTTP, REST, and JSON. So we don't really have for a lot of streaming options, which is really handy. And performance is again limited to JSON text format. And one more thing is gRPC protofile is easier to define than Swagger spec, which can be a lot longer and cumbersome. So what's the catch? So the catch is load balancing is still in the works for some networking tools like Nginx, but like the previous speaker showed, Envoy and a lot of service meshes already support gRPC, and uh, a lot of other features are already available for some tools, but some of them are still in the works. It's mostly a matter of adoption. Error handling is different in gRPC. You wouldn't have status codes, HTTP status codes with gRPC. So I was planning to show that, but let's see. And one more thing is dealing with gRPC from browser is difficult because it's not text anymore. So we have a gRPC JS now right now, but I've heard it's difficult to pretty difficult to adopt and use. So other than that, it's mostly a matter of adoption and getting used to gRPC, and but it really looks promising to me. Next slide, really. So a couple of things to learn after if I would have showed the demo, but let me just try to again show the demo if possible. Vinny, shall I give it a try again?
Yeah, I can definitely give it a try.
Let's see one last time. If it works, it works. Is it visible now?
It's visible, but the screen seems to be frozen, like you are presenting your screen, it says.
Now? I
Yeah,
think there's a
now
lag.
it works.
I'm not sure.
Now it shows me VS Code.
Okay, good. Okay. So I think I'll not go over all the examples and just go over two of them. So uh, so basically, what we can do is we can just pass this connection where we dialed to our gRPC server and pass the connection to our client. Like I said, the client is already generated from the Protos file, so we don't need to work for it. And what we have done is not really nice because if you can see, like you can call the method directly from the client which we have, and this client can have context a parameter. Now this is really useful if you think about it, because context can have timeouts and deadlines, which is really what we want with clients. With REST, we would have to manually, check the timer from our custom code, but this is really nice to have it on the framework side itself. And then you can just pass in the parameter for the method. It is pretty simple to calling a method from another package. You know the difference you have created the client, right? And then log the response. So let's just run it. Like this is similar to what we have done with gRPC SQL, but this time from code. So we have the name parameter, and that's it. So the next example. So what I want to do next is let me just comment this out. So sometimes you have requirements to. Okay, what's this complaining? Okay. Okay. I commented the wrong thing. Yeah, sometimes you have requirements to have arrays instead of just a single field. So you can use repeated field here, and there are a couple of other things you can do. Like you even have various data types here, and you can even have special data types. Special message types are something which are external to the gRPC framework. Google provides them, but there are special keywords like any, like literally any keyword, and you can use that to have any data type over there. But to our use case, this is sufficient. So let me just show this. Okay, so I need to compile the program message again. And and now this is happy. Okay. So we can run our server again now, and in the client side code, it is again pretty similar. I just I can just uncomment these lines. So this is pretty nice because we have methods to access the fields. So response is what we get back, right, from after calling the method. So we can just call the method and get the respective fields from it. So let me just show the code. I mean, just let me just show it so you understand better. So the name field was the value of the name field was CNCF and HashiCorp user group, and the array had CNCF and HashiCorp in it. So that is what we got from these methods. And just to write a simple thing, this is already created by profile. So I have another two examples, but I think I'm out of time. So I'll just show you what I actually intended to show. You can look it up later from my GitHub repo. So in this example, I had a parameter which was taken in, and we can. In the example, I had a handle within. So those were a couple of things I wanted to show, but due to time restrictions, I couldn't, and my hard luck. But moving on, there are things to learn as well with gRPC. Like you can utilize streaming, which is another feature, which is really useful, like I mentioned. And you can look at how interceptors and middleware work in gRPC. It is pretty simple. Another thing I mentioned was special program message types, which are external, and a couple of them are provided by Google, which are really handy to use. Another thing is exposing protobuf as REST endpoints. So here we have two methods. So what you do is define like get and an endpoint name, like whatever you want. Like you can do that. The transcoding can happen. There are ways to do it. So depending on your use case, you might want to look into that. Other resources says the gRPC documentation is pretty good. It wasn't before, but recently they have had great docs. And Nick Jackson, he's a developer advocate at HashiCorp who does this gRPC videos. It's where I pretty much learned from, and I would highly recommend you to check it out. But for starting out, what I have provided in my GitHub repo is pretty good. So I would recommend you to look at that. So thank you again, and I'm glad to take any questions.
Thank you, Harsh. Though you had some challenges, you managed to complete it.
Yeah.
If we'll wait for 1 or 2 minutes and we'll see for questions. If not, like you can answer them offline as well.
Sure, sure, sure. I don't think anyone
Yes,
has.
yeah, I think the attendees are also just dropping right away. So we just dropped 50% from 8 to 3 and then 4.
Oh,
Yeah. Okay,
okay.
then let's
Okay,
call
fine,
it
fine.
as a
We'll
meetup then.
close this.
Yeah. Thanks, Harsh. Thanks for
Yeah.
collaborating with
Sorry for
CNCF and
the.
yeah, no
Yeah.
problem. It like see, there is never a technical presentation without technical challenges. So it happens.
Yeah.
It happens. It's okay. It's totally fine.
Yeah. Thanks for understanding.
Yeah, yeah, no problem. Not at all. Like you don't need to apologize. You are one other organizer and you hold the same stake in this meetup. So yeah, thanks for reaching out to me and
Uh,
asking for a collaboration from HashiCorp Bangalore user group to the CNCF Hyderabad community. It is definitely a
yeah, glad
great
to collaborate.
meetup. Yeah, it is definitely a great meetup to collaborate and do it. Looking forward to collaborate in upcoming one of the meetups like sometime soon.
Sure. We can like let me know if there are any topic suggestions you've had requested from the users, and we can look at speakers for that.
Yeah, sure, sure. We'll do that. So I was just thinking that I'll just rotate it. Like I heard from Pune, Kubernetes Pune group, so they also wanted to collaborate. So I was just thinking, like,
Oh, sure, sure.
yeah, I was just thinking that even HashiCorp user group can do with some Bangalore or some again like Pune or something, and we can do this rotations and iterations. And it definitely seems like some great combination of tech talks are coming up like this. So it's good to see from Andrew, like. The Vault and Terraform and everything. So I liked it. The concept was a bit new.
Nice.
Yeah.
Yeah.
Okay, then
So we can even have Opa and Terraform or something like that at some point,
yeah, we
which
can
would
do
be
that.
cool to watch.
Yeah.
Yeah.
Okay, Harsh, then
Thank you again.
yeah, thank you.
Yeah.
Thanks for joining. Bye bye.
Bye.